So picking up where we left off, if we take a look at this triangle, so I'm just going to kind of sketch out a picture. This angle right here would be considered our exterior angle. So I'm going to call this one, I'm just going to use symbols. So let's call that a smiley face, a star. Let's add a frowny face into the mix, and then a heart. So the way that these rules work is that your interior angle sum always adds up to 180. So your 3 that are on the inside are always going to add up to 180. So in this case, that would be the star plus the frowny face plus the heart will always add up to 180. That's our interior angle sum rule because those 3 are on the inside. Our exterior angle sum rule says that to get the outside angle, I'm going to add the remote interior. And remote means far away. So I'm not going to add the star, I'm going to add the far away ones. So if I add the frowny face and a heart, so our grumpy person found love and now they're happy. That's how we get the exterior. And I could change it up and I could say to get the happy face, I add. It doesn't matter which way you set it up. You should get the same thing either way. Remember that symmetric property. So let's take a look at what that looks like with actual triangles, and then we're going to go ahead and classify them. So if I take a look at this first one, keeping in mind that all 3 are on the inside, which means that they're all going to add up to 180. So sometimes we can just subtract from 180 and keep it simple. Sometimes we're going to set up our equation. So if I combine like terms, I could just say x plus 65 and 57 would be 122 equals 180. And then to get x, I would just subtract that from 180, and that would give me 58. And that's it. Sometimes there's not a lot of solving in these, but don't forget that we need to classify them. So if I asked you what type of triangle is this when I have 65, 57, 58, all of those angles are less than 90, so that would be an acute triangle. So let's take a look at another one. A lot of times people see this box and they assume that it doesn't count, but it does. Go ahead and mark 90. Anytime you see a box, go ahead and just write down 90 and be aware that because you see a box, you're still going to include 90 into the mix. So if I combine like terms and I add these all up, they're all 3 on the inside. To set it equal to 180, that would be x plus 40 and 90 would be 130 equals 180. So that would just make x 50. And that's it. There wasn't much solving in these. Now, if I asked you to classify this triangle, this would be a right triangle because of that box, because of that 90 degrees. But for these particular triangles, I don't have any markings on the outside. I don't have any ticks. I don't have anything to know how the sides are. So all that I can describe them by is an inside word, like acute, right, equiangular, obtuse. So in this case, right, because of the box. So taking a look at the next one, always checking. Do you have 3 interior angles, which we do. So I'm just going to go ahead and do part plus part plus part equals 180. Those 3 interior angles will always add up to 180. So if I combine like terms, 8x would just be by itself. So 8x plus I have 2 and 60 and 70, so that would be 132 equals 180. And then I'm going to give you a minute to see if you can solve that. So our equations are getting a little bit harder, but not super difficult. If you subtract, you get the 8x equals 48, and that x equals 6. But in order for me to classify this triangle, I need to go back and plug x in. So 8 times 6 is 48 plus 2 makes that 50. And now I know all 3 angles are less than 180. So this would be acute. So taking a look at the next one, I want you to pause the video and see if you can set this one up on your own. See if you can set this one up on your own. So hopefully you paused the video. If you combine like terms, you're going to end up with 2x plus 154 equals 180. They're all three on the interior. Your x and x makes 2x, 59 and 11 and 84 makes that 154. And then from here, I'm just going to go ahead and subtract. So I have 2x equals 26. And then divide both sides by 2, so x would equal 13. And that's it. So sometimes the equations are pretty quick to solve. Sometimes they're a little bit longer. But as long as you remember that all three add up to 180, that helps you get started. And if I take 13 and then I plug it back in so I can classify this triangle, if I plug it in here, 13 plus 59 is going to give you 72 degrees. And then over here, 13 plus 11 would give you 24 degrees. And if you really need to use a calculator, that's okay. But if I check 84, 72, 24, it's not right. It's not obtuse. They're not the same number. So it's got to be acute. And those are how we have interior angle problems. Those are how we solve those. Now, if I look down here, you'll notice that you're going to see an exterior angle. So in this case, 120 is the exterior. Over here, x is the exterior. So for an exterior angle problem, remember that I'm going to add the far away. So not that close one, but I'm going to add these far away ones and set it equal to the exterior to get my answer. And that goes back to our frowny face found love. And that's how I get my exterior angle. That's our exterior angle sum rule. So for this particular problem, if I set it up x plus 50, so I'm going to add the far away ones, would equal 120. Subtract 50, so x would be 70. And we're going to skip classifying these just because we're missing some information. So that's it. Okay, over here, if I do the same thing, to get my exterior, I can add my far away interior. This goes back to remembering that the box means 90 degrees. So how are you going to find x? You're just going to add 70 and 90, which equals 160. So taking a look at this one, start by asking yourself, are they all three on the inside, or do you have an exterior angle? We have an exterior angle, so we're going to go ahead and add those remote interior, remote meaning far away. If they had told us this was 50, that's fine. I still wouldn't really use it because I care about these remote interior. So if I combine like terms with my remote interior, that would give me 5x plus 10 and 58, make that 68. So I could set this up two ways. Once I've added those, so I got 5x plus 68, I could say 5x plus 68 equals 11x plus 2, or I could say 11x plus 2 equals 5x plus 68. And then from here, I'm going to give you a minute to see if you can solve this one on your own. So if we put that letter on the left, so I subtract the 5x, I'm going to get 6x plus 2 equals 68. Subtract 2, so 6x would equal 68 minus 2 is 66. Divide both sides by 6. X would equal 11. That's it. Now, for this last one, I have two variables. I have an x, I have a few x's, and then I have a y. Okay, I have two rules. I know that the interior always adds up to 180. But my problem is that I have two different variables if I try to do that. So let's see if we can use our exterior angle rule. So our exterior angle is 12x minus 4. I can find out what x is if I add my remote interior. So 10x minus 10 plus 30 would be 10x plus 20, if I combine like terms, is going to equal that exterior, 12x minus 4. And it doesn't matter if you want to always keep your letter on the left or move to the right. I would probably subtract 10x. So I have 20 equals 12 minus 10 would be 2x minus 4. If I add the 4, I get 24 equals 2x. So 12, if I divide, would equal x. And symmetric property tells us that x equals 12. So I found x by using my exterior angle rule. What I want to find now is I want to find y. So I'm going to go ahead and I'm going to take x, I'm going to plug it in, and then we're going to see we've got a few options. Over here, if I plug it in, remember that 12 times 12 is 144. So 12 times 12 is 144 minus 4 makes this 140. And then over here, 10 times 12 would be 120 minus 10 would make that 110. And then from here I have a few options. Remember that a triangle always adds up to 180. But you can also remember that a linear pair adds up to 182. And that's what I'm going to do. If a linear pair always adds up to 180, and I know this is 140, 180 minus 140 would just make y equal to 40. And that's it. So that was our interior and exterior angle rule, and then a review of classifying triangles. Hopefully you remember some of those words from previous years or previous units. And that's it for today. Good luck with your practice.